Alright, example 8 is very similar to all the others. All these projectile questions essentially boil down to doing the same stuff. So we've got a particle projected from a point O and it moves freely under gravity, and we're looking for the length of time. It's 15 meters or more above O. So we start off, draw the grounding. Right, this is our point O. We've projected a particle up with 35 meters per second velocity and a 30-degree angle of elevation. Right, here we can see the trajectory, hopefully nice and symmetrical. That's a bit better there. And we're looking to know how long it's 15 meters or above. You might remember these question types from year 12 mechanics. There's quite a few of them when we were just looking at the one-dimensional Suvat type stuff with gravity, but actually it's very similar. So if we draw a line across here, okay, we can say that this is my line that's 15 meters above. And you can see that there's going to be 2 points on this curve where the particle is exactly 15 meters above the ground. Well, what's our strategy going to be? Well, if we find those 2 points, right, and we find the time that it hits here and the time that it hits here, then we will know that all of the time in between it will be above 15 meters. So we're going to find this time, we're going to find this time, and then we're going to find the difference between them. Alright, seeing as we're dealing with vertical height, we're going to resolve it vertically. So we can see that if we resolve it vertically, we know straight away without even thinking that A is minus 9.8, it always is. Gravity, S, we're looking for the point where it's 15 meters above. U is going to be 35, but it's not going vertically straight up, it's going with an angle of 30 to the horizontal. So if we're thinking about the vertical direction, we can see to get to the vertical direction we go away from the angle, so it's sine 30, and sine 30 is 1/2, so this is going to be 17.5 meters per second in the vertical direction. We're then looking for the time, so we have t equals, and then we're just going to solve this equation. So what have we got? We've got S, A, U and T, so again it's S equals UT plus 1/2 AT squared. So then I substitute in what we know, 15 equals 17.5 T plus 1/2 A, well that's going to be 1/2 times minus 9.8, so it's minus 4.9 T squared. Right, and we're looking to get T, we've got a quadratic in T. That should be expected really. We're hoping to get 2 solutions, right? The point where it enters and the point where it's leaded. So quadratic is good, it seems like we're going down that line. So I put it all on the same side and I make sure that's the side where we've got a positive T squared. Obviously we're not going to try and factorise this, we're going to use the quadratic formula. So we demonstrate that we know how to use that. T equals minus 17.5 plus or minus the square root of 17.5 squared minus 4 times 4.9 times 15 all over 2 times 4.9. And obviously we can get a little bit of assistance here by not actually using the formula, but by instead using the equation solver function on our calculator. Right. So we use 4.9 for A, minus 17.5 for B, and positive 15 for C, and we get 2 values. We get T equals 1.4285 and 2.1428. And again, if we think about that, that makes perfect sense, doesn't it? This could be 1.4 and this can be 2.1428. Yeah, that's roughly the right time frame. They're both positive answers, neither of them are ridiculously different, right? So that seems to make sense, so we're probably along the right tracks. So the final thing for us to do is just to work out the amount of time it's above it. So this is 1.42, it begins to be above 15 meters, 2.1428, it stops being above 15 meters. So time above 15 meters will be given by 2.1428 minus 1.4285. And notice again that I've used quite a lot of accuracy there. I know I'm going to round it to 3 significant figures at the end, but I just want to make sure that I don't round it prematurely and change my final answer by 1 decimal place or anything like that. So I get 0.7143, so to 3 significant figures, it's 0.714 seconds. Okay, that's the total amount of time that our object is above 15 meters.